Welcome to Qt e-Learning channel. In this lecture, we will discuss the short-term overheating stress rupture, including steam blanketing. Description of damage. Permanent deformation occurring at very high temperatures and typically relatively low stress levels as a result of localized overheating. It typically will result in bulging and eventual failure by stress rupture. If the temperature is high enough, failure will occur very quickly by tensile overload, since tensile strengths drop off dramatically at very high temperatures. At less severe temperatures, short-term creep failure will occur. Affected materials. All fired heater tube and boiler tube materials, and common materials of construction. Critical factors. Temperature, time, and stress are the critical factors. In heaters, it is usually due to flame impingement or any other cause of local overheating. The higher the internal pressure or loading, the shorter will be the time to failure. The local overheating is well above the design temperature. Loss in thickness due to corrosion will reduce time to failure by increasing the stress. In boiler tubes, it is due to steam blanketing or departure from nucleate boiling, which may result from flame impingement or restricted water flow. As illustrated in figure, the operation of steam generating equipment is a balance between the heat flow from the combustion of the fuel and the generation of steam within the water wall or generating tube. The flow of heat energy through the wall of the tube results in the formation of discrete steam bubbles, nucleate boiling, on the inside diameter surface. When the heat flow balance is disturbed, individual bubbles join to form a steam blanket, a condition known as departure from nucleate boiling, DNB. Once a steam blanket forms, tube rupture can occur rapidly as a result of short-term overheating, usually within a few minutes. Affected units or equipment. All boiler and fired heater tubes are susceptible. All steam generating units including fired boilers, waste heat exchangers, in sulfur plants, hydrogen reformers, and FCC units. Failures can occur in superheaters and reheaters during start-up when condensate blocks steam flow. Hydroprocessing reactors. Refractory lined equipment in the FCC. Appearance or morphology of damage. As illustrated in figures, tube ruptures are characterized by open fishmouth failure and are usually accompanied by a thin, knife-edged fracture surface, resulting from the excessive deformation and bulging prior to failure. As illustrated in figure, the microstructure of ruptured tubes will show severe elongation of the grains at the fracture surface due to the plastic deformation that occurs. Prevention, mitigation. Damage can be avoided by minimizing temperature excursions. Proper burner maintenance, management, and fouling, deposit control, are needed to minimize hotspots and localized overheating in fired heaters and boilers. Burners that produce a more diffuse flame pattern should be used in heaters. Proper boiler feed water treatment can help prevent some conditions that can lead to restricted flow in boilers. In hydroprocessing equipment, installing and maintaining bed thermocouples in reactors will help minimize the likelihood of hot spots. Proper system design and operation are also important. Refractory and refractory lined equipment should be maintained in serviceable condition. Inspection and monitoring. Short-term overheating damage or failure can occur in such a short time that inspection as a mitigative or preventive measure may not be possible. However, there are several inspection and monitoring methods applicable to dealing with short-term overheating. Components that are accessible during shutdowns, particularly in fired heaters and boilers, can be visually inspected to find tube bulging, sagging, and other types of deformation. Infrared thermography monitoring of heater tubes for localized hotspots could indicate locations susceptible to short-term overheating failures. Thermocouples can be installed to monitor temperatures of heater tubes, as well as other equipment, including refractory-lined equipment, during operation. Steam blanketing that results in long-term localized caustic corrosion rather than a short-term overheating failure may be detected by VT of the tube internals using a buroscope. Related mechanisms to short-term overheating stress rupture, including steam blanketing, are creep stress rupture and caustic corrosion, caustic gouging, boilers. Short-term overheating stress rupture, including steam blanketing. Summary. Description. Permanent deformation occurring at very high temperatures and typically relatively low stress levels as a result of localized overheating. It characterized by open fish mouth failure accompanied by a thin, knife-edged fracture surface. Temperature range. Local overheating. Affected metallurgy. All fired heater tube and boiler tube materials and common materials of construction. Prevention. Minimize localized temperature excursions. Proper burner management to minimize flame impingement. Proper, boiler feed water, treatment to prevent restricted fluid flow. Inspection methods. Visual observation, infrared thermography and thermocouples. Practice time. Question number 1. At relatively low stress levels as a result of localized overheating leads to Answer is D. Question number 2. Short-term overheating, stress rupture including steam blanketing is Answer is B. Question number 3. Stress rupture including steam blanketing damage causes bulging in the range of Answer is B. Question number 4. Stress ruptures including steam blanketing are characterized by Answer is A. Question number 5. The inspection of steam generation tubes subjected to steam blanketing should be Answer is A. This lecture is prepared by Samir Saad and this is his profile. Thanks a lot for watching and please waiting us for the next lecture.